will continue then in the same format, 2 minutes each. The first project to be doing their presentation will be ahead from the Centre Suisse d'Électronique de Microtechnique.
That's it. Good morning, everyone. My name is Hervé Saudon. I'm working as a senior project manager and activity manager at CSEM. So ahead in 2 minutes. Ahead is a follow-up project of ATTRACT Phase 1 swap project, which ended with TRL3 demonstrator of a pipe segment featuring built-in functions. So the objective in ahead is to further develop these pipe segments with the following built-in functions. We aim at implementing in-situ sensing, in-situ heating, and energy harvesting from fluid running through these pipe elements. And of course, to have these pipe elements operating in systems, they need to have electrical interfaces and mechanical interfaces at each end, of course. And to develop that, we will have 2 use cases that we aim at validating at TRL7. The first will be mechanically pumped loops for space applications with Thales as a use case owner, and CO2 industrial refrigeration systems with CERN as a use case owner and with the expertise of NTNU participating to that use case. So the message to take with you today, I think, is that in ahead we aim at providing technology bricks enabling in situ standalone monitoring for a large range of applications. That can be for fluid monitoring like water, gas, biofluids, oil, etc. But that can also be sensing and any electrical function that you would like to integrate in a tool, an end effector, a prosthetics, or any kind of element. So we are very interested to get in touch with any consortium or company dealing with such applications. And for that, you're very welcome to get in touch with me. And you have to know that there will be a call for additional use cases that will be assessed in ahead, and that will be around September.
Thank you very much. Those are the 2 minutes past already. The next project is a glass to mass from Glassoma in Germany and Austria.
Yes. Hello, good morning, everyone. Really excited to be here. I'm Dorothea. I'm the CEO of Glassoma. And we have been in the first phase. It's been a great first phase and really looking forward to the second phase now. Now, what are we doing? Our title has been a little cut off. It's actually all about high performance, high resolution optical components in fused silica glass, called glass to mass. We have a nice consortium consisting of Nanoscribe, EVG, and also OSRAM. As you can see, we are making glass optics. So what we actually did is we invented materials with which you can actually shape glasses like polymers. So you can use these materials and you can cut them, you can mill them, you can drill them, you can injection mold them, and then you can put them in the oven and then they turn into real high quality fused silica glass. So our objectives in the second phase are actually taking this great technology to using in mass fabrication, especially in nano imprint lithography and IALL, which EVG is expert on, and also developing the technology for the nanoscribe machine, high resolution thing. And yeah, that's basically all. We want to do this in the high scale industrial, and it's going to be a super interesting technology to save some energy as well. And we are interested in contacting all sorts of interesting people that I've already seen today. So we want to meet with people who have the scientific knowledge about advanced optics or high performance materials, but as well I saw some people who are experts on upscaling and entrepreneurship and really, you know, also getting infos on investments. So there's a real big opportunity to meet interesting people. And I think I can narrow it down after today. That's all from us. Thank you.
We will continue with HCube from the Consorzio Nazionale per la Ricerca.
Yes, good morning, everybody. I'm Marco Lazzarino from CNR in Trieste, and I will present HCube. HCube is a project aimed at developing new concept of low-cost, low-consumption, low-weight terahertz imaging detector, and it's based on the fabrication of innovative array of bolometers based on micromechanical resonators. Micromechanical resonators are like guitar strings. They slightly change their tune when they change the temperature, and if the temperature is caused by terahertz absorption, then we can use this change of tune to detect terahertz. Our preliminary results from ATTRACT phase 1 show a noise equivalent power of our system better than 100 picowatts per square root of hertz, which is very good if you consider that they are operated at room temperature. So the main advantage of our concept are the low cost, because these arrays of detectors are built using integrated circuit or micro-machine strategies. So each chip will cost less, few tens of euros. Low consumption, because there is no cooling required. There are permanent magnets and starting vacuums, which means no mechanical moving parts, and they will operate like an iPhone camera, and like an iPhone camera can be operating just using the power of a rechargeable battery. And then we have also to consider low weight for the same reason. So it could be something which is based on an airborne system, so it can be operated by a drone. So as I said before, the project is a result of the ATTRACT phase 1 project, but not only one project, but 3 projects merged together. And we brought the expertise and the concept for all these 3 projects and made the project very strong. And we also add the missing expertise, which are commercial, industrial, and also business development expertise, which have been joining our team. So let's say we have a very full and complete team. And now in these 2 years in front of us, we will demonstrate the technology, and we'll bring the technology to a high tier level. We'll start industrialization of the prototype, and we are also ready to raise the private funds to start a startup. So this is our plan in the next 2 years, and thank you for your attention.
Thank you very much. We will move on with the next project, which is HIPMED from Pentahomix in Israel.
Hello, everybody. My name is Boaz Brill. I'm the CEO of Pentahomix, which is a new startup just starting this year. And we are collaborating in this consortium with 2 leading technical universities, the Technical Institute of Technology and Ben-Gurion University, and also with Sheba Medical Center, which is the largest hospital in Israel. The questions we are trying to solve regard to cancer diagnostics. As you know, cancer is very complex and very personal. However, unfortunately, the biopsies that are taken from patients are not always being really utilized. So much of the information is not extracted. The standard method is taking a thin slice from the biopsy, from the tissue, and imaging under a microscope. And what we're trying to achieve is actually extracting much more information from these slides by staining them with immunological stains and imaging them with a hyperspectral imaging scanner, which we are developing in Pentahomix. If you want to imagine how much more information we are extracting, try to imagine the difference between a black and white image and a color image. So basically what we're doing is making a big jump, more than a color image, to extract much more information. This allows us to understand the nature of the cancer much better. And we are addressing specific applications in order to utilize this technology, mainly to improve the diagnosis of complex cancer cases where there are many subtypes of cancer that take different treatments, and the physician, the pathologist or the oncologist have to make a decision which exact type of cancer there is, and more down the road to utilize this information in order to match the best drug for each patient. We are very interested to collaborate with anybody who is interested in implementing AI for digital pathology, or has any information or interest in AI in images in general, and also for to collaborate with research centers looking at new technologies for biomarkers for staining.
Thanks a lot. I'm afraid you've reached your 2 minutes already. The next project is Hija from Aalto University.
Hi, everyone. Can you hear me?
Yes.
Yeah. So good morning, everyone. My name is John, and I'm working as a researcher in Aalto University. I'm also the project coordinator for an ATTRACT project titled as Highly Efficient Infrared Detection Unit based on high-purity bright germanium technology. Germanium photodetector is commonly used for infrared detection, which has become increasingly important for our society. There are several major functions for germanium photodetector, which includes, but not limited to, medical diagnostics for cancer tumor, nighttime vision surveillance camera, and scientific instruments used for biological samples. Although germanium photodetectors have been around for decades, the performance of them has been hindered by several factors related to the structures and fabrication technology used in the industry. Our project aims to address the optical and electrical loss of the current industrial germanium photodetector and to fully unleash the potential of it to the next level. Furthermore, we aim to expand the technology that we are going to develop into a three-dimensional coaxial photodetector, which further broaden the application of our technologies. In order to accomplish these goals, we partner with Baltic Scientific Instruments from Latvia, which help us integrating the photodetector into a fully functioning modules with other electronic components and cooling systems. We also partner with Optical from Belgium, which provide us the high-purity germanium crystal for subsequent processing. We are interested in connecting potential end user for this state-of-the-art detection technology and exploring other potential applications. And that's all I got for today. Thank you, everyone.
Thank you, John. The next project to present will be HYLIGHT.
Hello, good morning. Samuel Ojos Negros here from IBEC Barcelona. So I'm going to present the project HYLIGHT, which aims to develop a prototype to perform hyperspectral imaging on embryos from fertility clinics. Our consortium is composed by M-Squared Lasers, which is a big laser and microscope manufacturing company, by the Sheus, which is a pioneer IVF clinic in Barcelona, and ourselves at IBEC, the Bioengineering Institute of Barcelona. So the main goal of the project is to solve a clinical need that there is in fertility clinics right now, which is the lack of a tech-based diagnostic technique. So because of this problem, women need to undergo repeated unsuccessful treatments with the, that involves some physical and emotional trauma. So we want to make that technology more efficient. In ATTRACT phase 1, we did a proof of concept, and we proved that we can select embryos and we can classify them by their metabolic profile. So in this ATTRACT phase 2, our goal is to partner with M-Squared and build the minimum specification of a light sheet technology to implement our image analysis. Light sheets are very fast microscopes, very sensitive and cost effective. So we think is the ideal base for a diagnostic device. And we not only will try that in my lab, we will also do that at the Sheus, so to make sure that we comply with all the clinical routines and constraints. And we will be very interested in collaborating with a company that can make optical quality materials, because we need to modify the plates that we use to image the embryos. And that's it. Thank you very much.
Thank you, Samuel. The next project to present will be IALL, Integrated Adaptive Liquid Crystal Lenses.
Thank you. I'm Morten Gede from the Polytechnic University of Madrid. Our project is aimed at converting the lenses that we developed in the first ATTRACT project into final demonstrators. Okay, the consortium is made of the Polytechnical University from Madrid and AD Telecom, which is an electronics specialized company, and we have developed the the lens technology. Within the ATTRACT II project, our intention is to develop demonstrators that will provide illustration of the implementability of our lenses. We plan to make 4 different demonstrators, and we're looking at, apart from the financial aid from the technical development, then we're looking for the interaction with the ATTRACT consortium in the help of defining both the markets and potential joint venture partners. So what we're looking at is taking a technology which may be world leading and bringing it in to become a real commercial project. Perhaps not by the end of ATTRACT II, but at least reaching TRL level 7 in a number of different specific applications. We're looking for final working with the end partners, as well as with ATTRACT consortium members that might be interested in implementing a tunable lens in their setup. Thank you.
Hi, everyone. My name is Santiago Cartamil, and I am director of Scale Nanotech, which is the coordinator of MEGAMORPH project. MEGAMORPH stands for Market Entry of Graphene-based large area modulators with a radical production of holographic displays. And we are 7 partners from Estonia, Spain, the Netherlands, and the UK. And the consortium is composed actually by 6 companies and 1 research institute. We have planned the project simulating our future value chain, and the key goal is to demonstrate graphene-based holographic displays. This requires R&D of meta-surface front planes, developing and integrating custom backplane into display modules, and integrating electronics, firmware, and software into a display system. Finally, ATTRAGO will demonstrate and commercialize these high-resolution, low-power display evaluation kits for head-mounted displays, head-up displays, and augmented and virtual reality. And as a side effect, we expect to drastically increase the demand of CVD graphene and pave the way for its price reduction, as it is one of the bottlenecks for the commercialization of high-tech products using this material. We want to connect with people and entities interested in any aspects of business development, starting with H2020 experts that can help us in getting the maximum from the ATTRACT funding and the AIC accelerator. We look for support to develop a successful IP strategy and welcome contacts to raise private funding. We think ATTRACT has an extensive network that covers all these aspects. And in addition, we will also be interested in performing additional market validations and seeking strategic partners from this ecosystem. Thank you.
Thank you very much. We will continue with META-HILIGHT.
Hello, everyone. My name is Christopher Dierdal. I'm a researcher at SINTEF Oslo. I'm the coordinator of adaptive metamaterials for smart standalone histopathology with polarized light, short name META-HILIGHT. And with me, I have the partners from the University of Southern Denmark and the Oulu University in Finland. So our goal is to further develop an ATTRACT phase 1 project where we developed a digital diagnostic tool for tissue cancer detection. And it's based on using polarized light and looking at how the state of polarization changes upon interaction with tissue in combination with using AI. And the goal is to allow for improved diagnostics without the need for skilled technicians. Currently, histopathology is very work intensive. But the goal is to give a digital tool that will give you a quick diagnostic. And in this phase, we want to use adaptive metamaterials to miniaturize the system, allowing it to become portable and standalone. So we are interested in a lot of the topics that others have discussed so far, but in some keywords, we're interested in adaptive optics, biophotonics, on the research front, and in terms of industrialization, we're especially interested in upscaling for nano patterning techniques. That's all from my side.
Thanks a lot. We continue with Microquart.
Hello, my name is Mario Castañeda. I'm the research manager at Single Quantum. Single Quantum is a company that commercializes superconducting nanowire single photon detectors, and we participated in ATTRACT 1 in multiple projects in ATTRACT 1, most of them basically using a single detector. In this project, we are working with a company from Germany, PicoQuant, very well known, and we want to scale up what we did before to use basically multi-element quantum detectors. And the application is basically material science. So we want to develop a new system using their microscope and their timing electronics together with our single photon detectors. So the main objectives of the project are to develop these detectors, SNSPD-based detection systems with optical interfaces and detection areas, basically to comply with the microscopy applications. At PicoQuant, we develop a multi-channel TC-SPC system that will enable the full parallel readout of our detectors with very good timing resolution below 20 picoseconds. One outcome of the project will be a industrial grade system that we will validate at TRL7, and we will perform 2 system demonstrations. We're interested in contacting people, interested in material science, so who can be part of the end user pool that we are assembling. Also, in general, researchers in physics and biology interested in this approach. And I think there are, I have seen several potential synergies already. So any ATTRACT project, please contact us. Thank you very much.
Thanks a lot. We continue with Pipe 4.0.
Hello, my name is Luca Poletto from CNR Italy. I'm the leader of the project Pipe 4.0. It's a consortium which includes both research institutions at CNR University and University of Padova, and a spin-off from the University of Porto in nano energy, and 3 industrial partners active in the realization of instruments for gas monitoring, active in gas distribution chain, and active in production of biogas. So the aim of the project is to bring to high TRL level 2 past achievements from 2 past ATTRACT phase 1 projects. So one was gas Raman for the application of Raman spectroscopy to the measurement of concentration, composition, and heating value of natural gas. And one was energy for oil for the realization of an energy harvesting system to be used in the gas distribution chains. So we aim to realize 2 monitoring units for the monitoring in the gas distribution chain. One main unit with a Raman instrument able to perform a complete measurement of the gas parameters in injection cabins and following the distribution. And one is a network of distributed self-powered secondary sensors to measure the gas parameters in different points and give eventually feedback to the main monitoring unit. And we plan final industrial implementation in 2 different pilot plants. So one is an injection cabin for hydrogen-enriched natural gas in the distribution network, and one is a biogas generation plant for electric energy production. So we want to demonstrate in a real field of application these 2 past achievements of ATTRACT phase 1. So we are very excited to start phase 2. And obviously, we are interested to be contacted or to be in contact with certified international organizations, other research teams involved in the study of sensing technologies for hydrogen, particularly in view of distributing gas sensing, and other ATTRACT projects involved in energy management.
Thank you very much, Luca. I'm afraid you've reached your 2 minutes limit. The next project to present will be POSIX-2.
Hi, I hope you can hear me. I am Domenico Della Volpe, professor at the Geneva University that introduced the POSIC project that targets a demonstration of an innovative SiPM-based camera to be used in tumor lymph node detection or in radioguided surgery. The project is born around a new type of imaging camera. It's featuring an innovative position-sensitive light detector, but really the main driver of the project was to achieve the highest possible impact on patient management. The feature of the sensor are such that it can allow us to achieve sub-millimetric precision or even on a 3x3 centimeter square area just with few channels, and these give us the possibility to build an endable, very compact, lightweight, and wireless camera with a fast acquisition time. Really, we think that the strength of the project resides in the synergy between academics, the University of Geneva, the Foundation Bruno Kessler and high-tech company, and the Pin Lab of the Geneva University Hospital. As a matter of fact, we target the application, the device being designed and optimized also with the help of surgeons, which are helping establish the specifications required for the end user of the system. The system also has a potential dual user mode in the sense that it can work with both beta or gamma emitting radio tracer. And in the phase 1 study, we see that this kind of approach can really spot tumor of 1 centimeter, even if in 2-3 centimeters inside the patient tissue. So the question is that this kind of approach with high spatial resolution and precise localization will allow us to really remove the needs to opening a window in the tissue when searching for this kind of thing. And this clearly has a very important impact, a tremendous impact on the patient, reducing the surgery intervention to the minimum. The system has improved much wider field of application, but I mean, to go to market in surgery, this can be very complicated. We are looking really to synergy with other projects, but also we expect that ATTRACT can help us in really go and help us to find further fundings and get in contact with the possible funders to really move to the final product to the market. And that's it. Thank you very much.
Thank you. The next project is Random Power.
Hello. Can you see me? Can you hear me?
Fine, thank you.
Hello, so this is Massimo Caccia. I'm the project coordinator of Random Power. The target of our project is actually the development of a true random number generator platform, starting up by what we did during the ATTRACT phase 1, that is to say a single generator board about the size of a credit card, streaming out endless bits of random state to the end user. Now we want actually to evolve into a multi-generator board, which is targeted to data center, and we want to compress and to minimize everything into an ASIC. Out of bits, you get numbers, out of numbers, you have primes, out of primes, you get cipher text, and you get actually the keys. So our main application is cybersecurity. What we are targeting is actually to get in touch, since by now we're focused on the technology, on the end user community, both in terms of IT security companies and IoT companies, especially for the chip, and then also research teams and financial companies for Monte Carlo simulation. If you look at the consortium, you see that actually it's quite large, and it's embedding skills and competencies out of ATTRACT phase 1 project, that is to say people from Fondazione Bruno Kessler, Zenich, and WeRock. And these have been complemented by large corporates like now Gravision and Secor, which is a listed company, and by our spin-off. So if you see at the bottom of the line, you see Random Power, which is the spin-off company of AGH and Università dell'Insubria that was created by the end of the ATTRACT phase 1 project. This is it, and of course we will do our best. Thank you very much.
Thank you for your presentation. The next project will be Sniffer drone from the University of Barcelona.
Hello, my name is Agustín Gutiérrez from the University of Barcelona, and I'm the coordinator of this project, drone-based air pollution mapping for environmental monitoring and improvement of quality of life. And to develop this project, we put together a consortium with 2 universities, 2 research institutes, and 2 companies, which includes the University of Barcelona, ourselves, DAM, Depuración de Aguas del Mediterráneo, which is a company that manage wastewater treatment plants. Also the University of Lancaster, the Institute of Bioengineering of Catalonia, Gas Sensing Solutions, which is also a company that manufacture gas sensors, and Syntef, Microsystems and Nanotechnology Syntef Digital. And so the main goal of the project is, as the title says, the monitoring of pollution generated by industrial plants, mainly wastewater treatment plants, with a drone-based system. So basically, the goal is to fly over the industrial plant. And to do that, the first intermediate goal is the development of a high-performance multi-gas endir sensing unit. This will be achieved through the interaction of advanced tunable LEDs with highly efficient M-shaped light cavity and fast operation of MEMS control external cavity. And this unit will be capable of simultaneously detect 4 gases, which are important gases in the detection that are emitted by wastewater treatment plants, which are hydrogen sulfide, methane, carbon dioxide, and sulfur dioxide. And this unit will feature a fast response, a lightweight, a compact size, and ultra low power consumption, which is crucial in order to integrate it into this drone system. So the secondary goal would be to use this system to develop 3D mapping of wastewater treatment plants. On top of that, from these 3D mappings, we'll do other estimations. So using methods of machine learning, we will train these machine learning techniques to extract the odor from the 3D mappings that we obtained previously. And of course, the final goal, or one of the most important goals of the project, is to bring this into the system into a high TRL level. So we are starting up from a TRL level which was TRL 5, and we want to bring it to a TRL 7. And in doing that,
thank you. I'm afraid you've run out of your 2 minutes already, Agustin, so we must carry on. The next project is UltraRAM from Lancaster University.
Good morning, everybody. My name is Manus Hain from Lancaster University, and I'd like to give a bit of background to this project. So the memory market in terms of memory chips is worth in excess of $100 billion per year. 95% of that is DRAM, which is the main memory computer, and flash. Those two memories have very different characteristics. So DRAM is very fast, but unfortunately it's volatile. That means that when you turn a computer off the power, the information disappears. In fact, it has to be constantly refreshed every 64 milliseconds or so. It also has a thing called distracted read. On the other hand, flash is non-volatile. You can carry it around your pocket. It's very cheap, but it's very slow, and it also tends to wear out. So we're working on a new memory technology that is aiming to combine the best of DRAM and flash with none of the disadvantages, and that's called UltraRAM. At the end of the ATTRACT 1 phase, we had developed the memory on silicon substrate, so it's actually a compound semiconductor memory. The memory cells have a lifetime for the data in excess of 1,000 years. They have endurance, that is the cycling time in the memory, that is 2 to 3 orders of magnitude better than flash. And they also have a switching energy that is 100 times lower per unit area than DRAM. So in the ATTRACT phase 2 project, we want to develop the memories further and go from single bit devices to 64-bit arrays at 100 nanometers node or smaller. So that's scaling down in terms of the size of the devices and scaling up in terms of the memories, in terms of the bits per unit area. And we're interested in investigating or demonstrating 2 different applications. The first one is its use in data centers, and that is for environmental reasons, due to the reason that data centers consume vast amounts of electricity, and that is increasing. And we're going to model how the use of UltraRAM would actually reduce the energy consumption of BT, which is a large telecoms company in the UK and uses about 1% of UK.
I'm terribly sorry, Manos, but you've gone over time already. We have to stop you there and move on with Unicorndx.
Hi, good afternoon. Good morning. Hi, good morning. I'm Pepijn Beekman. I'm CTO for EasySense. I was a researcher on a phase 1 project, NanoDisk, where we invented a sensor that is the only one currently in the world where we can detect single virus particles in an integrated system. And we started a company based on that. We had some success. We attracted private funding. And now we're heading this consortium together with excellent groups in CNRS and Austria, University of Linz, because we're partnering up with them to combine the technologies developed in our mutual or our respective phase 1 projects, where we detect particles with direct current. They can detect molecules with alternating current. So we can use the same set of electrodes and have a multimodal sensing detection mechanism. So we can look at different aspects of disease. So for instance, you detect a virus, but you also detect cytokines, so that you have a diagnosis and a therapy suggestion at the same time. That's basically the idea that we're developing already with the company. We have some architecture and some infrastructure to increase the TRL to basically 9 once it's ready, because we're experienced in all kinds of certification. We set up a distribution chain, and we're interested in projects developing in vitro diagnostics. Anyone, maybe also students dealing with GDPR issues. And as I was listening this morning, I'd also be very interested in contacting groups of students which can help us think of how to use artificial intelligence to get the most of our insane jungle of data, because we're gathering huge data sets. So that would be very interesting.
Thanks a lot for your presentation. The next project is Vizier II from IFUNEA.
Hello, everybody. Can you hear me? Yes. Hello, my name is Andrea Ballabio, and I'm the coordinator of the project Vizier II. We are aiming to develop a dual-band visible sphere image sensor integrated in a CMOS foundry using silicon and germanium as a material platform for this technology. And we are going also to validate this technology that we will develop during this 2-year project, also in industrial environment and let's say natural environment, because we are devoted in 2 main areas. One is automotive, so we will use the device for validation in automotive for automatic driving and assisting driving for the car, and then also for some other more relevant challenges like wildfire detection and plastic sorting in natural environment. We are interested in keeping in touch with all the player and stakeholder that may be interested in sphere imaging application, and also with the project that may have some interest in sphere imaging, and so extending the standard imaging wavelengths and going further in the infrared.
Thanks a lot, Andrea. We will come back to Gabriella, since your internet cut you off and you weren't able to complete your presentation. If you are ready now with HCD Vision Air, you can try again.
Yeah, thanks a lot. So I keep it brief. My name is Gabrielle indeed. I'm currently a professor at University of Twente, and our project is related to help surgeons perform safe surgery by adding contactless spectral information to a head-mounted 3D display with which the surgeons can better make a distinction between critical tissues like nerve and veins in other tissue like fat or muscle. We had a successful ATTRACT 1 where we were able to demonstrate that we could offer the real-time 3D display, and we will continue now, especially by gathering a large data set from the humans during surgery to train our AI network on that side. For partners, we are looking for people who are specifically, how do you say that, expert in AR display design, and maybe as well high-end camera chip design. That would be the things that we might need in this project. Other than that, I think we are quite well set with 2 smaller companies that joined and want to integrate their specific equipment into this one product. Thank you.